Hello, this is a video which will introduce you and show you how to add MasterCAM into SolidWorks. MasterCAM is a CAD/CAM package, but before we dive into that, let's first talk a little bit about what a CNC is. A CNC is essentially a large machine, as shown in this picture, that allows you to machine a part using something called Gcode. Gcode is essentially a text file, a long list of character streams that instruct the CNC to machine a part. And a CNC can make a wide variety of parts. This is just one example. It is a bracket. Now the question is, let's say you want to make a part with the CNC. Do you want to hand code all this Gcode? Literally thousands of lines that you're typing in manually. No, I don't think you want to do that. I definitely don't want to do that. So instead of hand typing in that Gcode, what you do is you will utilize MasterCAM to interface with your part in SolidWorks, and then MasterCAM will generate the Gcode automatically. So MasterCAM essentially is an interface that allows you to go easily from a part designed in SolidWorks, CAD, to a real object made in a CNC. So now that you've been kind of introduced to the concept of MasterCAM and what it can accomplish for us, now let's kind of see it in action, at least a little bit. So I have this car that I want to make. It's composed of a motor, some wheels, a switch, a battery box, and most importantly, this chassis right here. And this chassis is going to be made out of HDPE plastic. So how are we going to make that chassis? One way to do it would be with the CNC. So here's just the part for the chassis, and what we want to do is utilize MasterCAM to generate the Gcode that can then be sent to the CNC so that this chassis can be machined. So in order to add MasterCAM into SolidWorks, you go here to Options, then you go to Add-ins, and then you go to MasterCAM for SolidWorks, check that, and say OK. A license agreement will pop up. You just scroll to the bottom of that. Of course, I'd say, you're legally obligated to read the whole thing. Luckily, I'm a very fast reader. Exit out of there, and this little green check mark will appear here. And you accept the license agreement, and it adds MasterCAM into SolidWorks. So now in the Feature Manager, you have this other tab over here. This is the MasterCAM Toolpath tab. Additionally, in your ribbon, up in the top, you also have another tab for MasterCAM. And I'm not going to go into the details on how I made all these toolpaths. That's going to be a later video. But what I will do is show you MasterCAM now in action and what it can accomplish for us. So this right here just represents the stock of HDPE plastic. This is what's going to go into the CNC, just a block of regular old plastic. But now that we created our MasterCAM toolpaths, we can see how it will be machined. Pretty cool to be able to go from a part that you made in SolidWorks to something that can actually be made. Now let's actually dive into making our part in MasterCAM. As you can see, all the toolpaths have disappeared. This is because we have started from scratch. First, there is a recommended workflow to use while utilizing MasterCAM. The first, make your part in SolidWorks, and as you're doing that, ensure that the design is realistic to machine. Of course, add in MasterCAM, set up your stock and origin, which we will get to, create your toolpaths, estimate the machining time, verify those toolpaths, create the Gcode, verify it, and finally CNC your part. So starting with step 1, we are quickly just going to go over the SolidWorks part. And as you can see, it's already been made, but I am going to make a few comments on how to ensure a realistic design. An important thing to keep in mind is that an end mill and a drill are both circular in cross-section. That means that any sharp corners cannot be machined. So if you have a sharp corner like this, you're going to have to fillet that. The reason for this is that your part that you design in SolidWorks should accurately reflect the part that actually gets made. So any sharp corners need an appropriate fillet. Additionally, the more pockets you have, the more complicated features, just the longer it's going to take to machine. That's another thing to kind of keep in mind as you're making your part. Now, the next step is to add in MasterCAM, which we've already done. And after that, we are going to set up the stock and set up the origin. Another important note about the SolidWorks is that the dimensions that you utilize to make your part must accurately reflect the stock that you are using. So, for example, this part is based on ultimately this initial extrude, this rectangle. And the dimensions of this initial rectangle should be based on the stock that we're using. And that stock is this rectangular prism of HDE plastic. So what you need to do from the get-go is measure the dimensions of your plastic, in this case the width, the length, the height, and then when you're creating your SolidWorks, ensure that the SolidWorks matches those dimensions. So in this case, I had a width of 3 inches, a length of 6 inches, and also a height of ½ inch. So that is reflected in my SolidWorks. So our SolidWorks is looking good. The dimensions of our part match the dimensions of our stock, and it is realistic to machine. Next two steps, set up our origin and set up our stock in MasterCAM. First, let's start with the origin. So right now you can see that the origin is really oriented in a funky way. We want to move that origin to the upper left-hand corner of our part, and we want the Z-axis pointed up. To do that, you go to View Manager, you click Top View, and it's moved the origin to the top of our part. Set that as our view. Make sure that the T here is matched to the view that we've selected, and hit the green check mark. In our case, editing the origin to place it in the upper left-hand corner is relatively easy, but in other cases it is a bit more difficult. If you are having trouble placing the origin in the correct location, you can actually create a custom view. In order to do that, you have to go to Geometry, and you have to choose a view to base your custom view off of. So you choose whichever view seems to match the best, click OK, and in our case, let's say the origin was kind of rotated the wrong direction. You can use these text boxes to rotate the origin into the correct position within your custom view. In our case, we don't need to do this, but this is just a quick note. Now, the origin is where we want it to be. Now, after we've done that, we need to set up the stock in MasterCAM. Remember, the stock is the piece of plastic that's actually going in the CNC. We need to tell MasterCAM what those dimensions are. So we go to Stock Setup, and then we just simply enter in the dimensions of the stock that we measured. Awesome, that's looking good. And if you want to kind of have a good visualization of what MasterCAM is thinking, you can kind of think about it like this. Those dashed lines represent the dimensions of the stock. So the stock and origin have been set up correctly. It is now time to create the toolpaths for our features. Let's start with all these holes. Since we want to make these holes with a drill bit, we go to Point Circle Toolpaths, and we choose the drill toolpath. Next, all we have to do is simply select all these holes. Once all the holes are selected, hit the green check mark. And then we can just choose to name these toolpaths whatever we want. And next is to define the parameters for our tool. I've already added in a few tools that are going to be in the CNC. For this operation, we want to use the 1/8 inch drill. And in a CNC, tools can be placed in various slots, and these slots are numbered. The drill bit, in our case, is going to be placed in slot number 2 in the CNC. So we want to make sure that the number we give this tool matches the slot that the tool is going to be placed in. So we tell it it's going to be placed in slot number 2 right here. And then for the feed rate and spindle speed, this depends on a wide variety of factors, the material that we're using, the diameter of the drill that we're using. In our case, we're just going to use some given tool parameters. For the 1/8 inch drill, we have a feed rate of 20 inches per minute and a spindle speed of 3,500. So we simply enter that in, 20 inches per minute and a spindle speed of 3,500. Next, remember, if we look back at the stock of the part, there are these screws that are going to be extending up from the surface. We want to make sure that the end of the drill bit does not hit these screws as it's moving around. So we need to tell it to retract between operations. And we do that by saying first that this measurement is going to be absolute. That means it's referencing this origin right here. And since the origin is on the surface of our part, we need to make sure that it's a little bit higher than 1/2 inch, because that's the distance that the screws extend from. Also, we want our depth to be relative to the origin, and we want to tell MasterCAM that the holes go all the way through the part by clicking a point on the bottom. Now, since we want these holes to go all the way through the part, we need to give them a little bit of a breakthrough. That will ensure that there's a nice clean hole all the way through the part. And it's that simple. Now our tool path is created. Let's now create the tool path for this large pocket right here. To do that, we go to 2D toolpaths, we go to pocket, and what we want to do is actually go to the sketch that we used to create this pocket, which is this sketch right here. Since this is an open pocket, it is important that the sketch extend off the part a little bit. This will ensure that no unwanted material is left behind in these corners right here. And we want to select that. Next, we can go to chains. If we select the chain, this tells us a few different things. First, this large green arrow right here tells us the direction that the end mill is going to move in. Additionally, this small arrow right here, that tells us on what side of this line the end mill is going to be on. Because it's pointing inward from the line, away from this wall, we know that the end mill is going to be moving kind of on the inside of this line, which is what we want. We hit the green check mark, and now it's time to define our tool parameters. In this case, we want to be using the 1/4 inch flat end mill. So we want to make sure that our tool is number 1, which corresponds to the 1/4 inch flat end mill. And for the feed rate and spindle speed, use these tool parameters. Feed rate, 30 inches per minute, and spindle speed, 3,500 RPMs. Now, since this is a relatively deep pocket, we don't want to cut it out all at once. What we want to do is step down a 1/4 inch and then step down the remaining amount. Don't need a breakthrough because this does not go all the way through the part. But again, we do need to make sure that we retract to avoid those screws, 0.75 inches, and that we correctly set the depth of the pocket. We just choose a point at the bottom of the pocket, and then I think we're good to go, and there is our pocket. Now our next step is to define the secondary pocket right here that actually goes all the way through our part. So to do that, again, we go to pocket, but this time we are going to select this sketch right here. So this sketch corresponds to this smaller pocket. We don't need this point, so we can delete that. And if we highlight chain again, we see this green arrow here. But one problem in this case is that it's kind of starting at a funky position. Instead, we wanted to start here, more on the outside of the part. We can do that just by hitting these arrows. And then another issue is in this case, you see the little green arrow is actually pointing into the wall. That means that the end mill is, instead of traveling on the inside surface of this wall, it's going to travel on the outer surface. It's going to cut off too much material. To switch that, we just click this button. And now it's pointing inwards, which is what we want. And I'm just going to go through these tool parameters quickly because we've already gone over it. But we do want to break through because now the pocket is going to go all the way through the part. We don't need depth cuts. To rebuild the part, if you've made an edit to it, you hit this button to regenerate it. And now it is looking good. The next tool path is this small pocket right here. This is where the switch for our car is going to be placed. So the workflow is similar. Go to the pocket and find that sketch that defines that pocket. We go here to the chains, and I'm just going to edit the start point. It probably was fine where it is. I'm just going to put it right there in that lower left-hand corner. Now, since this is such a small pocket, we actually want to use an 1/8" flat end mill instead of a 1/4" flat end mill. Those parameters are a feed rate of 15 inches per minute and a spindle speed of 5,000. So let's add those parameters in. Let's also give it a rapid retract, and we do want to have it step down because it is such a deep pocket. Make sure there's a breakthrough because it goes all the way through the part. And these parameters look good. We just need to change the depth here. And now I say we are good. There's our toolpath. Looking good here. I just want to check a few things on. Yes, we want to make sure rapid retract is selected on all of our pockets. That just speeds up the machining process. So the final feature we need to create a toolpath for is this pointy section on the front. In order to do that, we're going to utilize contour toolpath. So you go to 2D toolpaths, contour, and we're only going to select these edges here because these are the only pieces that will need to be cut. So after these edges have been selected, you need to check the chain. And you can see that the little arrow here is pointing into the surface. That's the opposite of what we want. Now that it's pointing away, we're good to go. And we now need to define our tool parameters. We're again going to use the 1/4" flat end mill. Set the parameters for that. We do need a breakthrough because in this case, we're cutting all the way through the part. And we need to ensure that the retract is an adequate height and that the depth is correct. So now we should be good to go. That is the toolpath there. That's looking good. So the final step is to backplot and verify all of our operations. So first, select all operations, and first we're going to do a backplot. So what we're looking for here is we're just looking at the tool paths and we're making sure that there aren't any lines that jut far off the part. We're looking to confirm that everything is how we think it should be. And then additionally, you can go to Info here on the left-hand side, expand that, and check the total time. And the total time is estimated to be about 7 minutes. In reality, it's going to be a little bit longer than that, but it's a good first estimate. So our time is reasonable. Now it's time to verify all operations. So first our holes come in, it's looking good so far. That first big pocket, the second pocket, now the smaller pocket for the switch. And finally the contour. And our part is looking good. Now that the toolpaths are created, the next step is to generate the G-code. To do that, you go to the feature manager and you press this G1 button. And then all you have to do is ideally save it on your USB drive as a NC file. Don't worry about that little warning that comes up, just press OK. And now edit it with Notepad++. And what we're looking for here mainly is just to make sure that our tool assignments are correct. So the 1/8 inch drill is assigned to tool number 2, that's good. 4th inch flat end mill is tool number 1, also good. And the 1/8 inch flat end mill is tool number 3, which is also good. So our G-code is looking fine. This is a video tutorial for the roughing and finishing features in MasterCAM. What we want to do is machine this part. First, we're going to use something called a roughing toolpath, and that's going to machine out as much material as possible without worrying about the finer details of the emblem. Then, we're going to come back with the finishing toolpath and machine more the details of the emblem. So first, though, we need to set up our stock. So you go to Stock Setup, select All Entities, and then hit the green check mark. Now, we still need to fix the origin. We want to put that in the upper left-hand corner. So you go to View Manager, you select the appropriate. So we do want the top, but we need to put the origin in a different location. So we're going to select this upper left-hand corner, and now it has moved our MasterCAM origin up there. So now that our stock and origin are set up, it's time to create the toolpaths. So first, the roughing toolpath. You go to Roughing Toolpaths here, and you click Rough Parallel. You can name it whatever you want. And now select all the surfaces in here that are going to be roughed out. Hit the green check mark. Don't worry about that. This is a cavity, so we're going to select cavity and then hit the green check mark. The check surfaces are the surfaces that we specifically want to avoid, and that is going to be this outside lip of the part. Now we want to use a 1/2 inch flat end mill. So select the 1/2 inch flat end mill. If you need to add it in, you have to go to Select Library Tool, find it in the list of library tools and add it in. In this case, it's already added in. For the feed rate, that's going to be 20, and for the spindle speed, that's going to be 4,500 RPMs. After we've selected the parameters, we want to go to this other tab, Rough Parallel Parameters, and we want to click the Max Step Over button and change the approximate scallop height to 0.01. Once we've done that, hit the green check mark. And it's thinking, and it has generated. Now that we've roughed out most of the material within this cavity, we now want to go back and do the finer details of the emblem. So in order to do that, we want to go to Finishing Toolpaths and do Finish Parallel, and now select the surfaces of the emblem. We don't need any check surfaces. And in this case, we want to use a very small end mill, a 1/32 ball end mill. So let's find that. It is right here, 1/32 ball end mill. We want this to be tool number 2. The feed rate's going to be 20, and then the spindle speed's going to be 6,000. For the finish parallel parameters, we want the approximate scallop height on flat 4 on the flat floor to be 0.01. Remember, this is what's going to be machining the finer details of our emblem. So now we hit the green check mark, wait for our tool paths to be created. So now that we have both tool paths, we can select both of them and validate them. Looking good so far. This is the roughing tool path right now. Its goal is just to remove a lot of material quickly. And you see that it doesn't actually machine the finer details of the emblem. That's going to be left to the finishing tool path. Now the finishing tool path comes in. This is the very small ball end mill that's going to be doing the finer details of our emblem here. And there it is, our finished part.